Alright, hello everyone. Today we're going to be solving LeetCode 167 twoSum 2 inputs array is sorted. So first we're going to start off by reading the problem statement. Given a one indexed array of integers numbers that is already sorted in non-descending order or ascending order, find the two numbers such that they add up to a specific target number. Let these two numbers be numbers of index 1 and numbers of index 2, where index 1 is greater than or equal to 1 and index 2 is greater than index 1 but less than the length of the numbers array. Return the two indices of the two numbers, index 1 and index 2, added by 1 as an integer array, index 1 and index 2 of length 2. The tests are generated such that there is exactly one solution. You may not use the same element twice. All right, so let's quickly look at the first example and why this is the answer. So these two elements here both add up to the target 9. So that's why the answer is 1, 2. Because this is originally index 0 and this is index 1. But since it's a one indexed array, as stated in the problem statement, we just add 1 to both of those. So 0 plus 1 is 1, and 1 plus 1 is 2. So that's why the answer is 1, 2. Now let's go over the solution. The most brute force approach would be to go through the array and just pair every two numbers with each other. But the only problem with that is there would be a nested for loop, and we just take every combination of two numbers. But that would be big O of n squared, which is quite inefficient. We want to have something that's a bit faster, maybe O of n. And how we're going to do that is a two-pointer solution, and we're going to use the fact that the array is sorted to our advantage. We're going to have a left pointer at the first element and a right pointer at the last element. And what we're going to do is compute the sum and see what it is relative to the target, and that's how we're going to move our pointers. So I'll quickly show exactly what we mean here. So let's say we add our a left and right pointer. So a left has a value of 2 and right has a value of 15. So 2 plus 15 is 17. And we say, is that less than or greater than 9? 17 is greater than 9. So what does that mean? In order to close the gap, because we know that two numbers have to equal 9 in this array because there is an answer, we need this number to be smaller. So how do we do that? Well, if we move the left pointer up, that means that every point that we move the left pointer up, the new sum will result in a bigger number because the array is sorted. So everything to the right is a larger number. And conversely, on the right pointer, if we look to the left-hand side, everything to the left is smaller. So if we change the right pointer, the next sum that we compute will be smaller. So since we know that 17 is too big, what we're going to do is move the right pointer down by 1 and recompute the sum. So we say, what's 11 plus 2? That is 13. 13 is still larger than 9. So we know we need a smaller number. So we can't move the left pointer because that would result in a bigger number. So we move the right pointer down one more time. And we say, what's 2 plus 7? That's 9. 9 is equal to 9, which is the target. So what we say is the left pointer is at index 0. The right pointer is at index 1. But since it's one index, we just add 1 to both of those. So plus 1, and we get 1, 2. And see, that is the answer. In this example, we only had to move the right-hand pointer, but the same rule applies if the number was too small. For example, let's say, just for the sake of completeness, let's quickly go over a counter example. So let's say instead the target was 22. So we had our left and our right pointer here, and we see that 15 plus 2 is 17. 17 is less than our target, which is 22. So since it's less than, we can't move our right pointer down because that would be a smaller number, which would get us even farther away from our target. What we should do here is move the left pointer up one position because that would be the next biggest number. So if left pointer is at 7, 7 plus 15 is what? 22. And that is equal to our target of 22. Hopefully that makes sense. If you have any questions, comment down below. So let's actually get into how we code this up. So first I'm going to zoom in so everyone can see. And what we're going to do is first make our left pointer. So left pointer will always be 0 for the first element in the array. And our right pointer will be the length of numbers minus 1 because it is a 0 indexed array and the length is not 0 index. So make sure I said minus 0, minus 1. And next what we want to do is have a while loop. We're going to say while left is less than right. And why we do this is because if our left pointer starts off at the first element and our right pointer is at the last element, once these two pointers cross each other, and left becomes larger than right, that means we've searched through the entire array and there's no more numbers to check. So that's how we know to break out of this while loop. It doesn't go forever. So while left is less than right, we're going to say sum, capital S, because the lowercase s is taken, equals numbers at index L for the left-hand pointer plus numbers of index R for the right-hand pointer. And here's where we actually move the pointers. So we're going to say with a couple of simple if conditions. So we're going to say if sum is less than, let's see, target. If sum is less than target, what do we have to do? We go back to our diagram. If the sum is less than target, so if 17 is less than 22, that means we need a bigger number. So which pointer do we move? Because if we move move the left pointer up, because that's the next biggest number. Because if we ended up moving the right pointer down, that would result in a smaller number, which would get us farther away from our target. So we want to move the left pointer up. So we're going to say left plus equals 1. Next, we have an elif condition. So elif sum is greater than the target. What do we do? If the sum is greater than the target, that means we need a smaller number. So we're going to move the right pointer down. So we're going to say right minus equals 1. And lastly, what we're going to have is an else condition. And if it's not less than, it's not greater than, that only means it's equal to. So that means we have our answer. We should return an array. And we're going to do L plus 1 because it's a 1 indexed array, and right plus 1. And this should net us our answer. So let's quickly try this out and see what we do. And there we go. We passed. And it's actually pretty efficient. So I hope you enjoyed the video. If you have any questions, comment down below. Peace.